Hey y'all, once again, I'm gone. I'm gonna be back on Thursday. We're gonna take the test on Thursday. I'm gonna give y'all today to review. I'm gonna go over each one of these questions. You got the link on here. You can see and watch again throughout the weekend, throughout Tuesday and Wednesday, and you can determine whether or not you need to rewatch this. What we have here is a triangle. Leg is 5, leg is 12, the hypotenuse is x. We want to know x. Okay. I cannot assume that these angles here are a 30, 60, 90 triangle. I can't assume that. All right. I have to go by what tools I have and information that I have right here. The tool that I want to use is Pythagorean theorem. I have two sides. I can use the Pythagorean theorem. So with this, my c squared equals my a squared plus b squared. I need to label this to make sure I put in the right values for c, a, and b. We always label the hypotenuse, the side that's opposite of the 90-degree angle, c. Then we have a and b as our legs. Subbing those in, x squared equals 5 squared plus 12 squared. I can type this into my calculator right here. X squared equals, I'm doing the math in my head right now, but that's 25 and 144. If I add those together, 169. And what I want to do is I want to solve for x, not x squared. So I need to counter the square. And the operation that counters squares are square roots. If I take the square root of this, I get that x equals 13. On the next triangle, same thing, Pythagorean theorem. C squared equals a squared plus b squared. Opposite of the 90, that's my C, the hypotenuse. My A and B are the two other legs. 10 squared equals 6 squared plus x squared. 10 squared is 100. 6 squared is 36. I had a student today, which is Friday, ask if you could go ahead and subtract the 6 squared before you actually take 6 and square and make it 36. You would end up with 4 squared, which gives you 16. Not, as we solve this, you can see 100 subtract 36 is 64. Way off from 16. So do not do that. Now we have our x squared equals 64. Take our square roots. We get 8 equals x. Okay, I also wanted to point out that these two problems, you notice how all three sides in both these problems, they're all whole numbers, okay? What we get off of that is what we call our triples, the Pythagorean triples. So this is a triple here. It's a 5, 12, 13. Simply means that anytime we see those, we could jump to that conclusion right away that the missing side, whichever one of these is missing, we could replace it with the 5. Or if the 12 was missing, we can notice the 5 and the 13. So the third of the missing side has to be 12. Okay. This one here is the example that I kind of harped on going over this, and that is the 3, 4, 5 Pythagorean triple. I called this one the perfect one because it was in numerical order. Any factors of these work, okay? So as I look at this problem, what we had here, we had the 10 here, and we had 6. And I wanted to find that missing side. So as I look at this, well, 3 times 2 is 6. 5 times 2 is 10. So we could say 4 times 2 is 8. So it's a way that we could use Pythagorean theorem, but just take shortcuts with that. So that was our Pythagorean triples. And the reason why I'm just kind of throwing this in here at the end is because if you don't know them, that's fine. You can do the Pythagorean theorem to keep in order. Okay, this next one. A lot of questions on this next one because people are trying to do Pythagorean theorem on it. It's a square. Okay, we know it's a square because all these four sides are x. All four sides are congruent. So it's at least a rhombus. Then two of these angles are 90, leaving these other two angles to be 180 degrees. Well, if we half them, because there's two and opposite angles are congruent, they have to be 90 also. And what you got to remember is that that line, that dotted line, that diagonal, is bisecting this square. It's cutting it exactly in half. So essentially, you have a triangle that's a 45, 45, 90 triangle. And this leg, the hypotenuse here, is 6 square root of 2. Treat it like a 45, 45, 90. Label it. Opposite of the 90 is x square root of 2. Opposite of the 45 is x and x. We can solve out what these legs are here by this information right there. What does x have to be? Well, if x square root of 2 equals 6 square root of 2, visually, they look very identical. Both of them have the square root of 2. We could take a guess that x is going to be 6. Proving it with using math, we'll divide by the square root of 2, countering the operation of multiplying by the square root of 2. And we do one side, we have to do to the other side, and it cancels out there, and we're left with the x equals 6. So each one of these is 6, 6, 6, and 6, because x equals 6. Rectangle, 24 by 7. We want to know what x is, this diagonal going across. I know two sides. The biggest mistake that people make is to assume that this is 60 and this is 30. Do not do that. Don't assume, okay? Go by what we know. We have two sides. Use Pythagorean theorem. Use PT. Off of this, as I would label this, my x would be where the c goes. My a and my b would be these other two sides. So, c squared equals a squared plus b squared. X squared equals 24 squared plus 7 squared. When I type all of that in my calculator, I get x squared equals 625. Got to get rid of this square by taking a square root, and the square root of 625 is 25. So x is 25. Okay, a rectangle has a diagonal of 2 centimeters and the length of the square root of 3 centimeters. Find its width. So I need a drawing. I have my rectangle. And it's talking about the diagonal being 2. And then my length being the square root of 3. Just like I talked about here, do not assume that this is a 30, 60, 90 triangle. We have two sides. Label it out. That's the missing side. So C is my hypotenuse, A and B. C squared equals A squared plus B squared. C is 2. A is X. And B is the square root of 3. 2 squared is 4. X squared doesn't change yet. Plus. Now, what's going to happen here? You got to remember that in math, we have counters to everything. Addition is a counter to subtraction. Multiplication is countered with division. And when we have an exponent like a square, we use the square root to counter it. So we have to take the square root of this. So what happens here is that we have a square root of 3, and then we square it. Okay, we're going to get 3. The square root and the square counter each other, okay, and we're left with what's inside. Mathematically, you can go the square root of 3 times the square root of 3, which is 9, the square root of 9, and then you get 3. So there you go, we proved it. Now finish it out. Subtract 3 from both sides, and we get 1 here equals x squared. I'm running out of room here. 1 equals x squared. Take the square root of that, and the square root of 1 is 1. Okay, find the length of a diagonal of a square with a perimeter of 16. So first off, we have a square, and the perimeter is 16. So what does that tell us? Well, perimeter means that you have all 4 sides that are added together. So when I add all 4 sides together, I get the answer of 16. Well, if all 4 of these sides have to be the same, I can take 16 and divide it by the number of sides, and I get 4. Each one of these is 4. Now I want to know, what is the length of that diagonal right there? Once again, from a square, this turns into a 45, 45, 90 triangle. And if the legs are 4, I need to find this side. I'm going to label opposite of the 45 is x, opposite of the 45 is x. That tells me right there x equals 4. Opposite of the 90 is x square root of 2. But we already know that x is 4. So this diagonal has a length of 4 square root of 2. Part 2 of this is the converse of the Pythagorean theorem. What we're trying to do here is identify if these are the 3 lengths of a line segment, can we put them together and form a triangle? In order for this to even happen, we have to say, well, A plus B has to be greater than C. We need to see if this makes a triangle. Once we know it makes a triangle, we'll do phase 2 of this, and we'll figure out, is it an acute triangle, a right triangle, or an obtuse triangle? So first off, which one of these is the C? C is always the longest. Do not let this confuse you. There's 2 9s here. Make one of them the C. That leaves the other 2 as your A and your B. So now 9 plus 3, is that bigger than 9? 9 plus 3 is 12. So yes. If this works, this is a triangle. Now that we know it's a triangle, we can classify it. And we're going to use the Pythagorean theorem to classify it. But instead of an equal sign, we're going to put this box. There's our Pythagorean theorem. C is going to be 9. We'll get that from right here, what we've talked about. Compared to 9 squared plus 3 squared. And 9 squared is 81. So you can type this in your calculator over here. 9 squared plus 3 squared. It's 81 plus 9. If we put that in our calculator, 90. Now, what goes in the box? Is it a less than sign, equal sign, or is it greater than sign? If you remember back to your alligator rules, and your alligator's always going to eat the bigger number, so the mouth of the alligator opens up to the 90, going back to elementary school there, you get a less than sign. And a less than sign tells us that it's acute. So you know, if it's equal, it's a right. Less than, it's acute. Greater than, it's obtuse.